morning. I have already been introduced by the team, but let me introduce myself as well. I'm Stuti Vajpayee. I've been working with EXL for last 7 years. Have more than 12 years of experience in Java and Java technologies and across domains. The domains that have already been mentioned. I have been working on Java for more than 12 years, and I think I learn new things every day because Java is a vast topic. And I, even though I have it was there in my college, even then during my working tenure, during my service, even then I'm learning new things every day. So it cannot be covered in 1 hour, but maybe we can provide you a stepping stone, and from there onwards you can start learning about Java. So today's agenda, we are hoping to cover the brief history of Java, its feature, platform, uh, something about object-oriented programming, because Java is an object-oriented language. We'll see how Java class is structured. We'll read about the data types. We'll learn about the access modifiers, some keywords that you will be using in Java, exception handling, multi-threading, concurrencing control, how multiple processes work together in Java, and introduction to J2EE or advanced Java or web technologies, if you may. So let us start. Here's a brief history of Java. Java is an object-oriented language. We'll learn about what is object-oriented later on, but it was developed by James Gosling in 1990s. And before settling up on the name Java, they had some more names in consideration like Oak, Silk, DNA, Ruby. And then they settled on Java, which is actually a sort of espresso bean originates in Africa, I think. And it was awarded as 10 best products in 1995 by Time Magazine. And it was, the project was initiated for digital devices like set-top boxes, television, and currently the Java has used in all spheres of software industry. If you can think about it's on internet programming, mobile devices, games are being developed on that. There are multiple e-business solutions across domains that are built on Java. It started with JDK 1.0, and currently it is at JDK 21. So you can understand how much it has evolved over the time. I started with Java 5, and now I'm working on Java 17, 21 being the latest one. One of the few of the major features of Java are the object-oriented language, which means the basic unit in which the Java deals is the object. So anything that you can think about in real world, a person, a student, a car, a table, all of those things in Java are represented as object. So object-oriented language. There are 4 pillars to that object-oriented programming, which we'll learn in later slides. Java is a platform independent language, which means you can write it on any machine, you can write it on any OS, and then you can take that program and can run on other environments, other machines, other OS, and it will work exactly like it intended to, like it worked on the platform you have developed it. It works exactly like that on other environments. So that's why we call it write once and run anywhere. Then it is secure, because in earlier languages like C, we had something called pointers that actually had addresses to the variable. So Java does work on pointers, but it is, in the background. It's behind the scene. Users do not get access to the pointers, and that's why it is a secure language. Multi-threaded or multitasking is one of the features in Java, which means how we work with shared resources when those resources are shared by multiple processes, multiple users, how we actually take care of that. That is considered under multi-threading. And In later session, we'll learn about how it is handled in Java. JDK, JRE, JVM. This we need to understand how Java is actually a Java program is written and run. So JDK is a software development environment which helps you to write your Java application, compile it, and run it. It includes the Java runtime environment, JRE, which has the interpreter, loader. It has the compiler. If any one of you have ever written a basic Java program, maybe you might have compiled it using Java C, and then your source file name, and that actually changes it to bytecode or the class file. And then there is archiver that changes your Java program into a jar file or a library. Then there is a documentation generator, Java doc, and there are other tools like that which help you to develop your Java program. Then JRE stands for Java Runtime Environment. It provides you the Java virtual machine instance where you actually run your program. It comes with the libraries that you require for your application to run efficiently. Whenever you write a Java code, I keep saying libraries. So whenever you write a Java code, you don't write each and everything. Like your program might want to read a file from the disk or read some data value. So obviously you're not going to write each and everything in your program. There are some pre-existing libraries, the libraries that are already provided by Java that you'll utilize. There are IO, there is package for file reading, which is Java IO, or you'll use package for database, like you can use JDBC to read the database objects. So those libraries are included in the Java runtime environment, and then the JVM. Now JVM is actually the instance that runs when you run your program, and that is, so whenever you actually write Java and then a program name, that actually creates a JVM instance inside which your program actually runs. So it roughly looks like that. You have a whole JDK, then you have your development tools for writing your program, then you have set of libraries that are going to help you run your program, which is under JRE, the other files, core files that you require, and the JVM where your program actually runs. Now I keep saying object-oriented programming, or Java is an object-oriented language. What does it mean? It means any language that use objects in programming. They use objects as a primary source to implement what is happening in the code. So suppose I want to write a program that takes that admits the users to a college. You enter a student to a college. So that student entity in the real world, for me in my program, will be a student object. That's why I say an object is a basic unit of object-oriented programming that represents the real-life entities. It will have the properties like a real-world student will have. It will have the enrollment. A student can have a roll number. Then he'll have a name, the course he's enrolling to. So all those things, I can keep it as an object in the Java program. Now, class is a blueprint. How this object will behave, how this object will be created, what all functions this object will perform, which comes under the method, is actually represented in class. So, if I create a class named student, I'll have enrollment ID, I have name and course. And now, if I want to deal with a student with name Ram, I'll create an object for him. So I'll create object like student Ram, new student. So new is the keyword we use for creating an object. We'll read about more keywords later on. So what I did, I had blueprint of student here, and I created an object Ram using this blueprint, which means my object will now have a property named enrollment ID, a property named name and course, and it will have values which corresponds to this Ram object. If I need to create another student object, I'll create student Lakshman, new student, and that will have object will have its own data to as a value to these properties. There are four pillars of object-oriented programming. First being abstraction. The only essential details are displayed to the user, and rest the low level information or design, you keep it hidden. So suppose there is a class called vehicle. Now a vehicle starts, a vehicle drives, and you can apply brakes on vehicle. So all these things, how it does it, it's not provided. It's just what it actually does. So you must have seen people wearing these smart watches. It actually records your step count, records your heartbeat. How it does it, you don't know, but you know what it does. So abstraction is providing what. So how we do it in Java, we do it through interfaces and abstract classes. Abstract class example you're seeing in front of you. So all these abstract methods, they need implementation, how they are going to behave, but we'll provide it in the lower classes or the subclasses of this class. We'll read about inheritance later. And the interfaces are same, like you created abstract class vehicle. If I need to create a instant interface, I'll create interface and then vehicle, and then I'll provide these methods, for which I'll need to provide the implementation, but abstraction is not about the implementation. Then the encapsulation. Binding everything that belong together as one bundle is encapsulation in a very layman language. So look at the example like class student. I've already discussed about the proper variables it has, the things that we can, the methods that we can call on student class, like get student info, and it will provide all the information of the student. So it is all encapsulated in a single class. So if I have anything to do with this class, it is encapsulated, it is bundled in this class student, and every data manipulation, every method that is required, it is in the class itself. Then inheritance. Inheritance, like the word, it means inheriting properties from your parent. In Java, from your parent class, or we call it superclass. So what we do, we just created in last slide we saw an abstract class vehicle. What we do, we extend the vehicle, which means we extend the behavior provided by vehicle. We have the start, we have the drive method, we have the apply brakes, and we'll provide the implementation according to our requirement. We may or may not implement. The vehicle in this case was an abstract class, so we are providing the implementation in this class. We can also extend the concrete classes, which means if we extend the concrete classes, everything that a concrete class does, the child class will be doing, until and unless we actually extend its behavior using the polymorphism, which we'll learn in a minute. And it will contain all the properties that the vehicle class or the concrete class have. We suppose vehicle had a variable called number of tires. So number of tires would be available to car itself. So this is how we inherit a property. We use extends for keyword extending a class. Now, polymorphism is controlling the method's behavior based on the object or the method signature. I keep saying providing the implementation of a method, providing the implementation of a method. There are two ways to do it in the polymorphism. There is one thing called overloading, which is you have same method, a method with same name in your class, but different signatures, which means it either returns a different type of object, or it takes different number of arguments, different type of arguments. So in the same class, you can have the same method name, but with different behavior. Then overriding, which is polymorphism through inheritance. The above example is example of overriding. So vehicle had all these methods. What we did, we override its behavior. This was the abstract class, this is the pure implementation. If it was a concrete class, even then we can override the behavior different from the concrete class, or maybe extending what it already does and applying our own changes over it. This is the example of overloading or same class polymorphism. In a class shape, you have draw, two methods named draw. But what is the difference? One takes two integer arguments and another one takes one. So based on that, the JVM will notice that, okay, so based on the argument, I need to call this draw method and not this one. So this is called overloading. Now, what is the typical structure of a class in Java? This is the class body. We have the class name and then the keyword class, which specifies it's a class, and then the name of the class. And in the braces, we have the whole block, which is encapsulation of all the data variables and methods that we need to call on this. Then there is called package. There's something called package, and the first line of every class is the package declaration. So what it does, like in encapsulation, I told you that we keep all the data types and all the methods required by one class and as one class bundle. Package is a collection of related classes. So in com.exl, I'll have classes that are related to each other in as one package. So I'll have student, I can have teachers, I can have courses, all those classes in one package. First thing is package declaration. One thing that is missing from this example are the import statements. Like I told you that we utilize different existing libraries to write our classes. So after the package declaration, we actually write the import statements. We import the classes from those libraries. So first, like I said, class and then class name. If you have noticed, the first letter of the class is capital. So this is the naming convention that we follow. The first letter should be capital letter. If there are two words combined to name a class, it would be student loan. Suppose it's a student loan class. So the S will be capital and L will be capital. There are going to be no spaces in between the class name. Then there is variable, contains data required by this class. We have method body. Again, we have method signature, and then in method in the braces, what all functions that we need to perform in that particular methods are kept in the method body. Data type tells us what kind of data does this variable holds. Is it an integer? Is it a string? So you see, int is a primary data type. Like there are others as well, like int, byte, char, and then there is string. String is a class. This is a Java class. So it can be, the data type can be primitive or an object or a class. Then we have access modifiers that tell us the scope of a variable or a method. Like here, public means it is available to all the classes and all the subclasses. There are other access modifiers also, we'll study them later. And the return type. Return type means what value is this method going to return? Is it going to return an integer? Is it going to return a string? Void means it is not returning anything. So if your method just performs some function and does not return anything, we use the return type void. The arguments are passed in the brackets, and these are the input parameters that method requires to perform a certain function. If you see this particular method, public static void main, for any JVM, for any class, this is the first method to be called, and from there the journey starts for your Java program. So it looks for this particular signature, public static void main, and then a string array type of argument. If your class does not contain this one, it does not know. It will give you, actually sometimes it will give you the error that main method not found. So from here, your method will start. Inside main, you can call other methods as well. Then there are certain keywords that you can see here, new, for creation of a new object. There are other ways to create objects as well, but new is the major way to create an object. And static here tells you that a particular method, or if I use it with the data type, or a variable, it means that this belongs to the class and not to the object, which means to call that object, to call that method, or to call that variable, you don't need the object, you can call it by class, and its behavior is going to be static for all objects that you create of this class. Now the data types. As I've told earlier, data types represent the type of data your variable contain. It is of different sizes and values based on the type that you're using. There are two types: primitive, that is Boolean, char, int, short, byte, long, float, and double. And then there are class types, object data types, or non-primitive, that is your string and array and integers, etc. Integer is a class, and int is a primitive data type. So when you write integer and then x, which means your x is actually an object, no object type, which means it comes with several methods that are provided in the integer class. And if it's int, it's a simple data variable that you have. Now the access modifiers. So access modifiers help you to restrict the scope of a class or a variable, method, or a constructor. Like you will specify what other members or external members do have the access to access this particular method or a variable. So there are 4 types. First is default. Default is I do not specify any access modifier. So if I write only void main or void get void set student or something like that, this means that this method or the variable that does not have the access modifier can only be accessed within the same package. So the class under which in which it is defined and the classes in the same package as this class will be able to access this. No other class will be able to access this member otherwise. Private is private to a class. So if I specify private method, or if I specify private variable, then this is not accessible to any other class or subclass. It is just scoped under this particular or containing class itself. Protected are available for within the same package, like default, or the subclasses in the different package. So if there is a class in different package which is not subclass of your class that contains this protected method or a variable, then they are not going to, they will not be able to access this method or variable. And then there is public, which like the name specifies, public to all the classes and all the methods and data variables. Errors and exception handling in Java. So what is exception? An exception is an event that disrupts the normal flow of the program. Suppose you wrote a program, a Java code, that reads a file from the disk. Now, you can write the correct syntax. If you won't write the correct syntax, obviously your compiler will give you error and you won't be able to run this program. But what if your program is correct syntactically, it has the correct syntax, correct logic, but there are other factors as well that can break the flow of your program. Like what if I remove the file your program is trying to read? What if the table that the data table that your program is going to read has been dropped or have been changed? The column that you are trying to access in that table has been changed. So these other factors, what they do, they disrupt the flow of your program, and those are we call the exceptions. The errors that are not due to the syntax of the code you have written. So there is certain hierarchy to it. We have already studied inheritance, how superclasses and subclasses work. There is throwable, and under throwable there are errors and there are exceptions. Now, exceptions can be checked exceptions or runtime exceptions or unchecked. Now, what each of these mean? Checked exceptions are exceptions that Java compiler requires us to handle. So there are certain code that Java compiler reads and it can tell that these particular lines can throw exception. So when you're compiling it on the compile time itself, it tells you to handle those exceptions. Otherwise, it won't let you compile. The unchecked exceptions are even when the compiler is not sure, if your compiler cannot tell if your code is going to throw an exception. For example, null pointer exception. So we have been talking about the student object and the method. How do you call a method on the object? We call it by object name dot method name, and in bracket we pass the arguments. So suppose I call student dot get student info, and the student object is actually null. So it will be null pointer exception because you do not have the student object. You cannot call the method on this. So these kind of errors are not, indicated by the Java compiler. You know it when you run your program. So these are the unchecked exceptions. Error, on the other hand, are usually recoverable. Suppose memory leaks, your library is incompatible, or things like that, where your program stops working and they behave like runtime exceptions, even though they're not in the hierarchy, they're unchecked. Now, how we actually handle the exception in a Java code. So these are 4 important keywords for exception handling. There are others as well, but these are the key keywords here. The try block. So in try, how we use try, we write try and we write braces. The code lines that are suspected to throw the exception, we keep them under the try block. So I told you, if compiler sees a checked exception in your code, it will tell you to handle it. So there are 2 ways you can handle it. One is the try catch. So you keep those particular lines that are suspected to throw an exception in the try block, and then you catch it. After you catch try block, you have the catch block, which is if an exception is caught, then what measures you want to take, what alternate code line do you need to run if there occurs an exception. You want to log an error, or you want to return a default value, things like that. Finally, we write try catch, we write the finally block, and finally block and everything that you need to run even if the exception occurs, that goes into the finally block. So what happens if you write try and then you write catch and then you write any code after catch? If there is an exception, that those code lines are not going to be executed. Your program will stop there and catch the exception and do what it requires to do in the exception case, and won't go through the remaining lines. But if you want them to be executed, no matter if the exception has occurred or not, then you keep it in the finally block. Throws if is used with the method signature itself. So you have already seen, you write the access modifiers, you write the scope, you write the return type of a method, then a method name, and then the argument it requires. With that, you use the throws keyword, which indicates that this particular method throws a certain exception. You write throws and the name of the exception this this method is going to throw. So this is another way. When you write throws in the method, the other method which is going to call this your exception throwing method, has to handle it. So like I said, your compiler knows that these particular lines, for the checked exception, that these particular lines are going to throw an exception, and then forces you to handle that. So if you write throws against your method, throws exception, the compiler knows that whenever this method is going to be called, it can throw an exception. So the developer need to handle it. And then there is throw. Throw, what it does, if you want to throw your own exception, like suppose you have written your own program, you got an exception, but that's a IO exception, that file not found. But you want to provide your own custom message to it, you want to provide your own exception to it, so you can throw and then you create the object of your custom exception and throw it like that. And then, of course, you have to specify in your method that your method throws your custom exception. Now, when I say custom exception, there are some existing exceptions that we have talked about, like file not found, class definition not found. There is null pointer exceptions, arithmetic exceptions. You can write your own exceptions as well. So for this, you just create a class with your custom exceptions. Suppose illegal argument exception, although there is an existing exception with that name, but anything like my custom exception, and then you extend the exception class, you override its method, and there you have your own custom exception you can use in your program. Let's see, look at the example. So suppose this is a class that throws the file not found exception. So what it does, it actually reads the file with the name that we have provided in the argument, and throws indicates that this method will throw file not found exception. Now, whenever we'll use this method in our program, our compiler will know that this method is going to throw an exception. So how are we going to handle it? We either just call this method here, and then handle it in the method signature, throws file not found exception. So what we did, we deferred exception handling. The method throwing the exception didn't handle it. The method calling the exception didn't handle it. But eventually, whatever is the calling method has to handle it, and then perform whatever actions we need to perform if we actually encounter an exception. Or we can write a program. We keep the method that is going to throw an exception in the try block here. And in the catch, we catch the exception, file not found exception, the object, and then what to do if the exception occurs. We'll log the error and we'll return the default value. Now, I have written file not found exception, how this argument works. I've written what exception I'm expecting from these lines. I can also write just exception, or I can write the super class. So I can keep going on the higher the hierarchy. So I can write file not found exception, maybe file not found exception, file not found exception actually extends the IO exception. So I can use IO exceptions object here as an argument. Or I can ultimately keep this exception. So what happens if suppose these lines throw an exception which is not file not found exception, your exception is not being handled here then, because catch block is not going to catch that. If I write IO exception here and it throws anything which is an IO exception, it will catch IO exception as well as file not found exception. And if I go further higher, I keep the exception block here. I can catch any exception then occurs there, and I can perform my action. You can write multiple catch blocks as well. I can write catch block. What if it's a file not found exception? Then I can apply another catch block below this one, which is IO exception. What happens if I find the IO exception? And then lower it, the exception. The object of the exception class, what happens if any exception comes. So what happens based on the type of object, my catch block will be executed. It's like you have the smaller net, then you apply the bigger net, and then for the bigger net. You can also catch the different exceptions that are not in the hierarchy as well. Then finally, like I said, finally is something that is going to execute anyways, even if there is an exception or not. And now the important Java keywords that some of them we have already seen, some of them you'll see when you'll start writing your own programs. Abstract, this term says that this method is, or the class needs the implementation. So any method that you mark abstract needs to be overridden. So like in vehicle class, if you remember, I have marked every method as abstract. So if I create a subclass which is by name car and it extends vehicle, my compiler will force me to override or provide the implementation of the abstract methods. In abstract classes, I can actually provide the definition as well, and I can provide the abstract class methods as well. Then new we have already seen, it is used to create a new object. For suppose you want to perform some block, you want to execute a block for a loop, you for a certain number of times. So that we use the for loop. So if you see here, for integer I equals to 0 till the time it's less than 5, we'll keep incrementing it, and we'll keep printing the value of I. So what is it going to do? It will print 0, 1, 2, 3, 4, and as soon as it is 5, it will exit this loop. Same is done using the while. We run a loop only, but while what it does, it just checks if certain condition is true. So while I equals to 5, suppose I provided a value of I equals to 2 in my method. So what it will do, it will keep comparing it with 5. So I suppose I write increment it here till the time it is 5. It will keep printing the value of 5. This we need to be very careful while applying. If we provide any condition which is always true, it is going to run till you get the memory leak, and you run out of the memory, because the condition is always coming true. So there should be an exit point. Either it's here or either inside the block itself. If and else, like I mentioned, condition, if you want to check any condition in your method, we do it using the if and else blocks. So right, whatever we write in the if block or else if block should return a boolean value, because it checks for either it's true or false. So if I is less than 5, it will print the value of 5. Else, which means this condition is not met, what I need to write, I need to write invalid number. This is how if else works. Final, I told you about the static, which is any method that you say static belongs to the class. Any variable that you say static belongs to the class and not the object, which means the behavior is going to remain same for all the objects. Final makes a method or a method final, which is it cannot be overridden. You cannot further change the behavior of this method. If you make a variable as final, once this variable is set, you cannot change it over the time. It is going to be at the same value throughout your execution. And if you can also use the final keyword with your class, and once you mark your class as final, it cannot be extended. You cannot modify its behavior by extending it this class. So this class will be the final blueprint. And like I said, static indicates a variable or method is a class method. Now, when I keep saying class method and I keep saying it doesn't belong to an object, how the execution actually works, when your class is loaded in the JVM, first things that are loaded are the static, excuse me, sorry, static blocks, which means they're executed as soon as the class is loaded in the JVM. So whenever you change the behavior of a static variable, the other object accessing this variable will see the same value. It is not going to be changed. And like I talked about the static block, which is you mark static and in the braces you write certain code. When your class is loaded by the loader, these variables will be loaded. These lines will be executed, and then that's it. During the loading itself, it ran. When you create the object, those whatever those lines have made the changes will actually be reflected in all the objects that you create after the class is loaded. We have already discussed throw and throws and synchronized. Synchronized is something that we use in the multi-threaded environment. If you mark any method as synchronized, only one process at a time is going to access it when you are carrying out the parallel execution. To understand this more, we need to understand the multi-threading. And this is the keyword used to indicate the current object. So if in a class I say this dot enrollment ID equals to 1, which means whenever I'll create an object and the object calls the method with this line, this means the current object itself. So if I created the object Ram and Ram calls a method that has written this, so it says Ram, for Ram it is this dot id equals to 1. So for Ram object it will set the id to 1. So Java and multi-threading. So concurrency in Java refers to the ability of Java platform to run multiple operations simultaneously. So there are two essential components to it: threads and processes. So suppose you need to access a file, you need to read a file and tell its and return its contents to the user calling it. You have thousands of users and obviously they cannot read one by one. You want your process to be faster. So what you do, you perform the multitasking, which is each user is able to access the file simultaneously. So how we do it, we create the threads which are lightweighted process, and each thread is going to access that file parallelly, so the process is going to be faster. Now suppose we need to write in this file. Whenever we want to write in this file, obviously we cannot do it two processes writing at the same time and reading it, and they might read the wrong value. So at that point we want one thread to access this file at one time. So that's where the synchronized keyword that we have seen before comes into play. So what is the life cycle of the thread? Need to go to this one. When I write the thread, I can write it in two ways. I can either extend the thread class or I can implement the enable interface. Both of them has the run method where we actually write the execution, how this class is going to be executed, how this thread is going to behave, or what is the function of the thread. It is written under the run method. Then we just call this thread and we call the start method on this. And what start does is it tells that the thread is ready to be executed. How it is going to be executed is on the JVM. When it is going to be executed is on the JVM. But JVM, what it actually does, it calls the run method to perform the threads functions. Now we can come to the life cycle of the thread. So as soon as I did start, it brought my thread to a new state or an active state. That okay, my thread is an active state a new state it's ready to be executed. Now JVM will see its queue, and if it is ready, it will bring it to active state, which is it brings it to running, which means now it can access the CPU resources, it can access the resources it needs. Then if during the execution we want to block the thread, we want it to be in a waiting state, we can call multiple functions like methods like sleep, which actually blocks like makes the thread to sleep for a time that we have provided. We can call wait method on it, which means it will wait for until it is notified to start running again. And then we can set it to the waited time wait, which is it will wait for a certain time. But that doesn't mean if the time is over from the sleep and wait, then it will start executing again. Again, it's on JVM if it wants to keep it in the running state and then run the execution. And then the terminated or the dead form. Either if it is terminated due to some error, or it completes its execution and it's terminated. This is the whole life cycle of a thread. That's why I actually brought to the methods before. So as soon as you start call the start method on a thread, it is in JVM queue, and now JVM will call the run. Now, since see, it's a public void run, which means you can call the run method directly, which means you could have called t1.run. What would have it done? So you are actually taking away the thread's benefit here, because you are actually telling the JVM to actually run this method. It's not static, so it's not JVM that is running it. You simply call the run by yourself, and now this thread is just a process that you have called, and it's It's not the JVM that is calling the shots. Now we'll learn about J2E or the web applications. We go to the browser, we write a URL, we see a website, or we call a REST service, we call a web service there. So all what is happening in the background is a part of advanced Java or J2E. So what is J2E? It's a Java E facilitated development of large scale applications, web applications mostly, and the servlets. It's a structured application which separates the three layers: the client layer, the client or the user which is accessing a resource or a website; the business layer, where all the business handling of the processes going on. Like you see a website, you see a portal, you write your student ID and you press get student info. So the business layer actually takes care if this user actually authorized to see the information, what information should we transfer. So that comes in the business layer. And then there are integration layers. Where is this information being fetched from? Is it another web service that this method is going to call, function is going to call, or do we need to access it through from the database? And then a simple web application, how it looks in the Java project. There are Java server pages. If any one of you have ever seen an HTML page where it has head and the title and the body, and then different form attributes like text box and buttons. JSP is that plus the JavaScript syntax along with that. So within those HTML pages, you are actually writing your Java code. Then there are servlet. These are the Java code that serves your request. It actually extends the HTTP servlet class. We'll see an example which works with the HTTP servlet request and response object. So request is what you get from client. That enrollment ID that the student entered comes in the request object, and the response that we are returning, all that data this person requires goes under the response object. And then we have web.xml, which is a deployment descriptor. What deployment descriptor does is it provides the mapping. So whatever URL you are using, whatever servlet name you are providing in the URL or in the form function, that okay, when I enter when I click on this button, I should get this service. So all those requests are mapped in the web.xml. So how we actually what servlet are we going to call, and how is it going to take care of our request, that all comes under the web.xml. And then Java beans and entities and DTOs. So like I said, Java deals with the object. So you asked for a student info, you provided an ID. So obviously there would be a student object that would be created in the background, and from there you will be getting all the information. So what it does, it actually create the bean or the entity or the DTO with the name student, and then you get all the information. That's an example. CSS, so you have ASP and the HTML, you want to look at a certain way. So it's more about the styling, how you style the page. Now, when you create your web application, how you run it, you actually host it on a server, and then it is available for other users to access. So there are two types of servers: web servers and application servers. Web servers, simple servers that actually provide you the hypertext transfer protocol, HTTP services. You have examples like Apache, Tomcat, or Raisin, and you provide a request through a website, and then you get the response, and which you are redirected to another web page. So all that web server. Application server is that web server and additional features like EJB container, your entities, your DTOs, and how the business logic works. So it comes with the web container as well as your application logic. So your EJB container, so that will be your application server. JBoss is one of the examples. So I said we'll see at the servlet example. See, it's a simple class only. If you see here, it has the package. There are import statement. So I am importing an IO exception class. I'm importing a print writer. I'm importing a servlet exception. So all what it does, it just the libraries and imports their classes in my class. So I can actually access their method now. I can import my packages and my classes as well. In public class, it is public, available to all other classes. It extends the HTTP servlet, which means it extends the method of the HTTP servlet class. And then we have a do post method as well here. So protected, what does protected do? It is accessible to my subclasses and my subclasses and other package. And here it throws the servlet exception, which means whichever method is going to call this to get, it has to handle servlet exception and my exceptions. And then I am using the response object to set the content and content type and content whatever I want to write. When I say out.println hello world using HTTP servlet class, when I actually will call the servlet class using the URL on my browser, I'll see a page with this written in the heading 1, hello world using the HTTP servlet class. And how I got it from the response object, which was created in the server. Now, like I said, JSPs, HTML plus the JavaScript, you see here, hello, the time is now. This is the Java object. We're calling the Java class here. And how we write Java in the JSP pages, we use the scriptlet text, which is angle brackets and then percentile, and whatever we write in here, we can write our Java code here. There are some explicit objects that are already available to JSP. You do not have to create these objects like we created in HTTP servlet. So request is already present here. You can directly write request.get context path and it will get you the context path of your URL. Then response object is already there, session is already there, out. So the time here is now when I said equals to, I'm actually returning a value here. If I remove the equals to and if I just write out.write and provide this method in its bracket, java.util.date, it will write the date using the out. So this was the basic application that we saw, basic web applications, but nowadays we work with the frameworks which are more sophisticated and requires us to write less code and getting it simpler. So we have struts where we provide the mapping using struts.xml, what URL takes us to what action file. We have JSF, we have Spring is again vast topic, the dependency injections and inversion control, and actually provides us liberty from creating the object and takes care of itself. We have Hibernate. Hibernate is the ORM. It's a framework that helps us to access the database. Generally, when we access the database, we write a boilerplate code, which is JDBCs, providing the JDBC drivers, creating the connection, creating a statement object, then getting the data from the database. Hibernate simplifies that and deals with the object. Each row is represented as an object in Hibernate. And then there are Google Web, and there are other frameworks that we use for it. So that's like everything that I could cover in 1 hour. Is there any question? I'm glad to answer that. Samara, please, can you explain more? More regarding what? I'm sorry, I missed that. What exactly? Which topic?
I think she's asking about static keyword.
Yeah.
Static keyword. Okay. Yeah. So static you use in the variables, like I said, static int. Suppose I write static int pi, and there is a class that performs the mathematical function, although the pi is already there in one of the packages. But suppose I write static int pi equals to 3 static double pi equals to 3.14. So what happens if I create, and this I'll call this called my calculations. So it doesn't matter how many object of this my calculation I create. I can create my calculation C1, my calculation C2, my calculation C3. For C1, C2, C3, the value of pi is going to be 3.14 only, because it's actually connected to class, not to the objects. If I change it using some object, if I change the value of that variable, then it will be reflected on other two objects as well. Same goes with the method. And also I told you, when we call the method, we call it using the object, which is called object dot method name. But when we are calling any variable or method which is static, we call it with the class name. So I'll call my calculation name of the class dot that variable name or dot that method name. I think I confused you with the static block. So in a class, when you're writing, you can also write a static block, which is you write static keyword, and in the braces you write certain code. Suppose you are reading a property file, and that is something that you only need to do once, and whatever that function does, it should be available for all the objects you will create from now onwards. So the static block is loaded when your class is loaded, because it's not related to an object. So you read a property of pi, suppose you read the value of this static variable pi from that property file that you have created. So you read it in the static block itself, and after that you don't need to read it again and again. So when the class loads, your pi is initialized to the value in the property file, and then it is available for all the objects. One thing that I forgot to mention, thank you for asking for more explanation. Static variables are only accessible in the static methods. Static methods can only change the static variables. They cannot change the object variables, because again, like it's for the object static, but the non-static method can do it. It's vice versa.